Okay, so I just want to go through this. This won't be quite as long as the last one, so this should just be about 5 minutes. So now we're going to talk about formal proofs in proving triangles congruent, which is a little bit different because I wanted to get you guys started on this. So these are all the properties. Actually, reflexive property is the one property that we're actually going to be using. Reflexive property just says something is equal or congruent. So side AB is equal to side AB. Side AB is congruent to side AB. Angle ABC is congruent to angle ABC. And then here I just go through all of your properties of equality. So addition property of equality, if you have one side equals another, if you add the same side, the sums are going to be the same, the differences are going to be the same. If you multiply each side for sides, it's going to be the same. Next thing is, so here we have substitution property of congruence or equality, which just basically says if AB is equal to CD, then any CD I can replace with AB. And then this transitive property says AB is equal to CD, CD is equal to DE, then AB is equal to DE. Okay, so there's just a connection there. All right, so I would highly recommend highlighting things as we go through. So we're given angle BDT, so that's going to be this angle here, is congruent to angle GTD. Okay, these two angles are congruent. Okay, when you're doing a proof, you have two columns. You have your statement and you have your reason. It's like going to court. So my first statement is, well, I know, this is what you know, angle BDT is congruent to angle GTD. How do I know that? That was given to me to be true. So I just write the word given. Okay, next thing I know, I'm also given that BD is congruent to, so BD is congruent to GT. And you can do the little congruence mark. I like highlighting, and so I put that also in my proof. Okay, is congruent to GT. That's also given to me. Okay, so look at this right here. I'm trying to prove that these two triangles are congruent. Right now, I have a side and an angle. Okay, and so I need a third piece of information with this. And so I'm looking at this right here, and I notice that they share the side DT. Okay, and I know that DT is congruent to DT, and I just gave you this. This is called reflexive property. Make sure you write it correctly. Said that something's congruent to itself. So now I have three things in three things. Is this a way to prove congruence? Well, I have, they're both included angles. Okay, so they're both included angles. So I know for sure that BTD must be congruent to triangle GDT by side, angle, side congruence. All right, let's try another one. So here we're given angle B is congruent to angle D. I always write it in my proof and mark it in my diagram. How do I know? That's given to me. All right, I'm told that in the proof. Okay, that's what given means. I also know that AC is congruent to EC. That is also given to me. So AC is congruent to EC. I need a third piece of information, okay, for sure. So I have a side and an angle. I either need another side or another angle. And I'm looking at this diagram, and there's something else I know for a fact that's true. I know angle, and this is, you have to be really careful with this. I know angle BCA must be congruent to angle DCE. Okay, and that's called vertical angles theorem. And you cannot say this is not angle C is congruent to angle C. It is not that, okay? There are too many angles in that spot. So I know that that's true. Now I have two angles and a side. And so I know that that's a way to prove congruence. So I know triangle BCA must be congruent to triangle DCA. And then I just want to make sure I look, and this is non-included side. So this is the non-included side. So this is going to be angle, angle, side congruence. And you can write postulator theorem if you want. Okay, last two, just really quickly, you're given AB is congruent to AD. So that was given to you. You're also given BC was congruent to DC. That was also given to you. You need a third thing. You notice that they share AC. And so the question is, how do you know that AC is congruent to AC? Well, there's a property that says something's congruent to itself, and that's going to be reflexive property. Okay. Now I have three things. Once I have my three things, I look and see, is that a way to prove congruence? I have three sides and three sides, so I know triangle ABC is congruent to triangle ADC by side, 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 congruent. And then last, but not least, is this one here. I'm given angle B is congruent to angle D. This one's a little bit trickier. That's given to you. Okay. And it also tells me, and there's really not much I can write with this alone, because I can't mark anything. C is the midpoint of AE. So I write that that was also another piece of information. It's like going to court. This is something that was given to me. But if C is the midpoint of AE, then I know that AC must be congruent to CE. And how do I know that? Well, that's by definition of a midpoint. Midpoint divides a segment into two congruent parts. So that's what you'd write. That's how I know that those two parts are congruent. So right now I have two parts congruent. All right, now I need to look for the third. So when you're looking for a third part, look for things like reflexive property. Also look for vertical angles. So in this case, I know this angle and this angle are congruent to each other. So I know that, and I know I shouldn't have done this because this is also going to be angle side. I know that angle BCA must be congruent to angle DCA. Okay, because of vertical angles theorem. Okay, now I have enough information. I can say triangle BCA must be congruent to triangle DCA by angle side congruence. I didn't mean to have two of those, but that's how you do proofs. They're not so bad. I just want you to try it out, and we'll talk about it more next class on how to do a proof. But I want to see what you guys